What is the cloud? Well, let's compare to the word set. Set has 464 definitions in the Oxford English Dictionary, making it the most defined word in the English language. While the cloud, or cloud computing's not quite on the same level as set, one could argue that it's just as hard to define. NIST, the National Institute of Standards and Technology, defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. In layman's terms, cloud computing can be described as the ability to access various types of information, such as videos or social networking, without having to provide your own hardware. Cloud computing's origins are many, although two computer scientists, J.C.R. Licklider and John McCarthy, are generally acknowledged with identifying the key concepts in the early 1960s. Licklider's vision, an intergalactic computer network, would have everyone around the world interconnected and accessing programs and data from any site, anywhere. John McCarthy, on the other hand, proposed computation as a public utility, similar to the service bureaus which date back to the 1960s. Major milestones in cloud computing include the creation of Salesforce.com in 1999. This company was responsible for pioneering the concept of delivering business applications through simple websites. 2002 saw the birth of Amazon Web Services, a collection of Internet services which included storage, computation, human intelligence through the Amazon Mechanical Turk, and the Elastic Cloud, or EC2, a commercial web service that provided small companies and individuals the opportunity to rent computers on which to run their own applications. In 2009, Web 2.0, a term that advocates the materialization of a new World Wide Web, hit its stride, as numerous companies began seriously offering web-based applications to businesses and consumers alike through services like Google Apps. And finally, perhaps the most important contribution so far has been the emergence of killer apps. These applications deliver web-based services that are very reliable and easy to use, the end result being greater confidence in and acceptance of online services by the consumer. Cloud computing has many uses in business and can be categorized generally into three different segments. First is SaaS, or Software as a Service, a software delivery model in which software and associated data are centrally hosted within the cloud. In a business environment, this could consist of CRMs, email, CM systems, virtual desktop applications, and other items. In this model, cloud providers install and operate application software in the cloud, and cloud users access the software from cloud clients. Next is Infrastructure as a Service, or IaaS. IaaS is the most basic cloud service model in which cloud providers offer computers as physical or more often as virtual machines, raw or network storage, firewalls, load balancers, and networks. IaaS providers supply these resources on demand from their large pools installed in data centers. Local area networks, including IP addresses, are part of the offer as well. For wide area connectivity, the Internet can be used, or in carrier clouds, dedicated virtual private networks can also be configured. And last is PaaS, or Platform as a Service. PaaS consists of execution runtime, databases, web servers, and development tools. PaaS provides the entire infrastructure needed to run applications over the Internet. It's delivered in the same way as a utility such as electricity or water. And like a utility, PaaS is based on a metering or subscription model, so users only pay for what they use. Most organizations will access cloud services through one of four different deployment models: public, private, hybrid, or community. Public clouds consist of companies that provide cloud services to a single or multiple customers. Customers can consist of large corporations or single individuals. iCloud or Amazon's EC2 would be examples of this type of deployment. A private cloud is exactly what you'd expect from the name. The cloud is private and accessible only to the organization which deployed it. This requires the organization to maintain and manage the cloud on its own. Hybrid clouds are simply a combination of public and private clouds. A public cloud could be used for greater scalability and access, while mission-critical applications and data could reside within the private cloud. And finally, we have the community cloud deployment model. Cloud services would be provided and shared by organizations within a community. This could be useful for companies which want to work closer with their business partners. Local, state, and federal governments could also share computer resources by deploying community clouds. Now let's talk about some everyday examples of cloud computing and put a name to the face, so to speak. As you'll see, the cloud's been a part of your life long before you had ever even heard the term. The first example is web-based email services such as Hotmail, Yahoo, or Gmail. Webmail's main advantage over the use of a desktop email client is the ability to send and receive email anywhere from a web browser. Another example of everyday cloud use is voice over IP, more commonly referred to as VoIP. VoIP eliminates traditional phone lines in favor of the Internet and generally is lower in cost. Skype, probably the most well-known VoIP provider, allows for video calling so you can see who you're talking to anywhere in the world. And the most widely used example of cloud use could be social networking applications, such as Facebook or Twitter. Many things must be considered when instituting a cloud computing environment. Foremost among them are data privacy, integrity, and protection. Standard security controls may not be enough to protect information that's manipulated or stored in a cloud environment. A standard used to select other types of computing requirements, including hardware, software, storage, and transmission, should also be employed when considering a shift from conventional computing methods. Security and data protection can depend on several factors, such as data sensitivity, the cloud provider, their security guarantee, an accurate risk assessment, and an understanding of the technology being used. Initially, it's the responsibility of the end-user organization to identify data sensitivity and to balance the risk of loss with the cost of protecting it. Details such as location of data and ownership should also be considered. After completing the risk assessment, it's advisable to research cloud providers for a model that fits your needs as closely as possible. Upon finding one, you'll need to fully understand the provider's security guarantee or warranty, and then decide whether it fits into your data security plan, or if you'll have to negotiate an agreement which can add considerable cost. End-user responsibilities within a cloud computing environment will also include handling local security, such as virus software, maintaining updates, restricted internet usage, and centralized security protocols. You'll also be responsible for the physical security of hardware used, such as laptops, smartphones, and tablets. As we've seen, cloud computing comes with many advantages, but also some disadvantages. On the plus side, cloud computing requires a business to pay only for what they need at the time. Cloud computing also grants small and medium-sized businesses much easier access to technologies at a lower price point. It simplifies the conduct of business and does not require IT-like personnel. And since services in the cloud can be accessed anytime from any computer, it's easy to collaborate with users in distant locations. And on the downside, well, when a cloud service is down without warning, you could be left without important information. Another concern, can your data be recovered once you stop using the cloud service? And how much data are cloud companies collecting, and how might that information be used? Federal compliance mandates may also prevent some companies from accessing the cloud for data storage and service applications. Problems such as automatic scaling can also make cloud computing financially surprising. Additionally, a denial of service attack by hackers could raise costs since the attack would keep your servers busy. As our daily lives become more connected at home as well as at work, cloud computing is the next step in making the delivery of services and resources more cost-effective and efficient. Efficiency is the number one benefit of the cloud, and in the next few years we'll see even more of this migration taking place. Some experts believe that by the year 2020, the cloud will almost completely replace the personal computer. Most of the software used by consumers and the tools that access information online will go through servers owned by firms that could be hundreds of miles away. Others believe that we could have an Internet of Things, where everyday items will each have IP addresses connecting them to the Internet. But for the time being, people are using their personal computers, tablets, and smartphones with intuitive user interfaces in conjunction with cloud technology to satisfy their computing needs, both at home and at work.